Okay, so some had some questions. Let me quickly read them and see. Okay, so few things. What do you need to know for titration? So all the steps. So even the apparatus, drawing it, knowing how to calculate concentration. It's very important there. Then if I give you something like there's always going to be a titration, you're going to have some unknown substance and some known substance, right? One with a known concentration. So then you're going to titrate in the known concentration, for instance. Could be the other way around. Usually you titrate in the known concentration, and you'll see when a color change happens. So you need to know which indicators to use, okay, and the color changes of those more or less. So which indicators are important in terms of if it's a strong base and a weak acid, or a strong base and a strong acid. So then you need to know, okay, strong base, strong acid, probably going to be about neutral. Then you use the indicator that's closest to neutral. If it's, let's say, a very strong base and a weak acid, then you know it's going to be a higher pH where the new endpoint is of the titration. So then you're going to use phenolphthalein, for instance. And then the other way around, if it's a strong acid, weak base, then it's going to be ending at a lower pH. So then according to that, you have to be able to choose the correct... let me just check. Sorry, I had a phone call. So you have to choose the correct indicator for that. Then you have to be able to do like a mini experiment, like that practical we did. There might be questions all the way through from anything in that practical. So in other words, you should be able to know if I added 25 milliliters of, usually it's 25, let's say an unknown substance in my Erlenmeyer flask, I titrate in some other substance, then I can record how much of the other substance in order for it to reach the endpoint. Using that, I can then calculate the moles of the known substance I added. I can look at the balanced equation and see, okay, according to the ratio it reacts, and then I can get the moles of the unknown substance it had to react with. Okay, so using the volume and concentration of my known substance, I can calculate the moles of the known substance. Moles of the known substance in a mole ratio, normal stoichiometry, quantitative chemistry, I can get the moles of my unknown substance that it had to react with. And then from the moles of the unknown substance and the volume that I put into that little container, guess what? You can get concentration, moles over volume. So you should be able to do that entire little thing in order to determine things. There can even be trickier questions there. I think the matrix had one where they had to get molar mass, for instance, if I told you the grams added or whatever. So, but it's just going to be like an extra step. That's the base thing. So you need to know titration all the way through. Now, next thing that Summer asked is oxidation numbers. So yes, Summer, your idea of what to know for the oxidation numbers is correct. You didn't go all the way into reduction, oxidation, reactions, and electrochemistry. So that's going to be next year. For now, all you guys really did was identify the oxidation number of a element inside of, let's say, a reaction or inside of a compound. So Zama's explanation is very good. If you have calcium carbonate, CaCO3, then you have to know the oxidation number of the C, the calcium, the Ca, and the O, and the rules based on that. So then you know, okay, the O is going to be -2, the C is going to be 4, and Zama said the calcium is -2, I believe, Zama. Let's see. If you guys don't believe Zama, leave a comment. I'm not in a state right now to calculate this in my head. Very tired. Okay, next. Hydrolysis of salts. Okay, so hydrolysis of salts, in this kind of section, I don't have your textbook with me, so I don't know everything that's in there. According to what I know, it's not necessarily all of it. More in the sense of that, I think it was a cycle test you guys wrote, where it was questions where it's a metal reacting with a non-metal, that type of thing that you need to know. All those different types of, metal reacting with an acid or base or whatever. All those kinds of reactions, we needed to know, okay, something with a hydroxide reacting with a metal, or all those. There was like 6 of them. Sorry that my brain can't get the exact words right now, but you guys know that little cycle test we had to do with oxidation numbers and all of those acid base and acid metal type reactions. Those things you need to know. I think your textbook goes more into depth next year's type of work on hydrolysis of salts. You don't need to do all of that there, only the things that were relevant for our cycle test that you need to know. pH of salt solutions, you just need to have an understanding of pH. You don't need to do any of those KW things or those things with concentrations over each other, those calculations. That's next year. You don't need to do any of those things. Even the graphs, most of them know. The only graphs you need to be able to know is the titration curve we looked at, and you can see what happens in a titration curve. So you can look at that. Otherwise, the hydrolysis of salts don't focus on that too much, as long as you can do what you did in the cycle test. So again, I don't know exactly everything that's in the textbook. I don't have one with me. They took mine. It's at the school. So that's the big thing. Now, another thing that Zama asked is physical properties, melting and boiling. So what do I actually mean by that? What do you need to know? So again, you need to know the basics, grade 8 type work. You need to know your grade 10 type of work where you know, okay, this melting and boiling points. Think of those other graphs of phase changes. You need to know where phase changes happen, why phase changes happen. So in other words, phase changes happen. Oh, and I'm thinking of a typo that I made answering, I think, cat. I'll get to that now. So you need to know intramolecular forces and intermolecular forces. So we added a lot to the intermolecular forces, so the forces between compounds. Why does a phase change occur? Because when you heat something, you're adding energy to it, enough energy to overcome the intermolecular forces between them, okay? And then overcoming that allows them to escape, let's say as a gas, or to move further apart and become a liquid. So you need to know that phase changes happen because of that. Higher melting and boiling points means stronger forces were actually overcome. So the higher melting and a boiling point, the stronger the intermolecular forces. And you have to be able to link that to the different types of intermolecular forces that we have. So we had those hydrogen bonds, the dipole-dipole London forces, and then induced dipole forces as well. So all those types of different intermolecular forces and the strengths of those forces, and even knowing why it's a hydrogen bond, for instance. So being able to say, oh, it's with nitrogen, oxygen, fluoride. So in other words, a small, high electronegativity molecule, and that it has a lone pair of electrons. So in that molecule. So those types of things. You also need to know polar, non-polar in that section as well, and know whether a molecule is polar and whether a bond is polar, because they are different. Molecule, about the shape and arrangement, so the distribution of electrons. If they're not distributed evenly, so a lot of electrons this side, none on this side, then it's going to be a polar molecule. On the other hand, then this links a bit with what Kat asked as well. Kat asked about exothermic and endothermic. Yes, there are exothermic and endothermic things in there. There are some definitions even in there. There's some, might possibly be graphs. There might possibly be identifying whether a reaction was exo-endothermic. You guys need to know your energy of reactions, reactants and products over there. So if reactants are here, products over there, then you know, okay, there's like a little loop like this with the activated complex up there, activation energy, all of those things. Your delta H, which is your heat of reaction, if I remember correctly, just double check me. Those types of things you do need to know, and you need to know the relevance of it, that energy is absorbed from the environment or released to the environment, those types of things. Again, a lot of that is grade 10 level things that you've done there before, so you guys should be happy about that, but you do need to know it. Other than that, a lot of the quantitative chemistry in the test, I haven't covered absolutely everything that's in there. I covered questions specifically from Summer and Kat. And then they did ask questions about good things, because a good portion of marks for exo and endothermic, and a very good portion of marks for titrations, especially since it's grade 11, specifically new work we did. Very important. The bonds, also new work we did, so there are going to be questions on that. The quantitative chemistry always will be a part, and then organic chemistry, remember, up to the high level that we did in those even those small class tests, of being able to know that flow diagram, one into the next, reactions, right? It's not going to be as easy as just identifying, naming, drawing. Now there's going to be a reaction component to it, and knowing the names of the reactions, what type of reactions, different types of things, whether they will react faster or slower, how to differentiate between, let's say, an alkane and an alkene. There's a test for that, for instance, or knowing whether something will be an alcohol or an ester or whatever. Being able to name all those things, very important. Hopefully this helps. Unfortunately, guys, you can see I'm in a garage. I don't have a whiteboard with me. I don't have a textbook. I don't have specific examples. Unfortunately, I'm going to a wedding as well, so I don't think I'd have time to get to things. If I can, and you guys ask other questions, I can maybe get examples or get a piece of paper out and try and scribble something. I don't know if I'd have time, but I'll try my best for you guys. So hopefully this helps a tiny bit. Okay, thank you, and miss you guys. And then, yeah, don't hesitate to contact me. I think Zama and Kat now have my email address, so ask them. Also give it to some of the grade 10s that might ask questions for you guys. It's muester13@gmail.com. So there you have it. I know Miss Pandram would like that as well. So if you know her, send her just my email address, and then she can contact me. I think she had a question and I never got to it before they took away my email and everything. Okay, bye. I'm just talking nonsense. Study.